Here's problem 5. It wants us to find the critical points. It wants us to determine whether they're maximums, minimums, or points of inflection. Now when we start with this, it's to the third power. I know that this guy's going to come down, bend up like that, and then bend back down. That's anything that's an odd power. X to the third, X to the fifth, X to the seventh, so forth is going to do that. In this situation, we're going to have a minimum right here, a maximum right there, and a point of inflection where it's sort of bending this way and then bends that way right there in between them. And that's what we're looking for, these 3 critical points. Now, how do I find them? Well, again, the way we find these is if you take the derivative of this equation, that's going to tell you the slope at any point on this graph, at anywhere on it. Well, right here, what is the slope? Well, the line tangent to it's going to have a slope of 0. This guy up here will have a slope of 0. So we can find the maximum and minimum, the maximum there and the relative minimum there, by taking the derivative of this, setting it equal to 0, saying, hey, the slope is 0. Where's the slope of 0? And then find the x value that works. Plug it back in here to get the y value for it. So let's do that. Let's take the derivative of this. The derivative, bring your 3 down, that's 3 times 3 is 9x squared, minus 2 comes down, 36x. Now we want to set this equal to 0 because we want to find when this guy, because this guy right here has a slope of 0, and right here is a slope of 0. So this describes the slope at any point. Well, let's set it equal to 0. So I have 9x squared minus 36x set equal to 0. I now saw, well, a 9 comes out, that's quite obvious. A 9x comes out. I'm left behind x minus 4 equals 0. Either 9x is 0 or x minus 4 has to be 0. Solving that, one solution is 0, the other's 4. I'm going to plug it back in here. Now I don't know whether that's the minimum or maximum. I do, but I'm not going to do it. You're going to have to figure it out. Let's figure the ordered pair that goes with 0 and 4. Well, when I plug 0 in, 0 there and 0 there, I'm going to get obviously negative 4. Think about it. That height is down at negative 4. When I plug 4 in here, it's going to be a little big, but let's see what we get and see what the height is. That's 64. 4 to the third is 64. 64 times 8 is what, 192? So I got 192 here. Okay, minus 4 squared is 16. 18 times 16, well, to be honest, should have thought about this before I came down here, but that's okay. 8 and 6 is 8. 4, 108, 0, 8, 1. I got 8. I got 288 minus 4. Well, this guy's going to be quite far down there. 192 to that, minus 4 more, looks like negative 102 to me. 92, if it said 292, 292 would have been 100, so that was negative 96. 4-way, 96, 4. Well, negative 100. I don't know where I got that 102. Sorry about that. So 4, negative 100. That's way down there. This would have been my minimum then. And this right here would have been my relative max. And again, it's relative minimum because it's not the lowest point on the entire graph. It's just in that particular location. So that would have been at 4, negative 100, swung back up here to 0, negative 4. So there's your max, there's your min. We still need this point of inflection, which will be between them. But let's go ahead and know that we do it by taking the second derivative. So the second derivative here, I'll do it right here, second derivative of the function is 18x minus 36. We set that equal to 0. Pull 18 out, or you can see x is going to be 2, because 18 times 2 is 36. Also, like I said, in the middle of those guys. So when I plug 2 in there, 2 cubed is 8. That'll be 24. Minus 2 squared is 4. 4 times 18 is what? 72. Because 20 times 4 is 80. Go back 8. Yep, 72. Take away 4 more. Okay. 30, 42, 48. I got negative 48. Take away 4 more. I got negative 52 there. And that's going to be our point of inflection. Point of inflection. Sorry about the messiness there, but again, you're going to be much neater than I am, and you'll be working things and have your little calculator with you to help you out. So nothing wrong with using your little mind every once in a while. So our maximum 0, negative 4, minimum 4, negative 100, and our point of inflection 2, negative 52. There you have problem number 5. Good luck with it.